When we throw a coin into the air, we are aware of that it will return. Everything is because of gravity. Gravity is the cause of our existence, as well as the solar system's development, and despite being universal, the first place is the energy that is most enigmatic. Scientists have been exploring the universe, the origin of it for a while, but now scientists are conducting a study. Things will completely alter our world. Knowledge of the universe for all time. They assert to have discovered the true origin of gravity. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. How and where is this investigation going? To alter how we perceive the cosmos and how it provides the solution to our design. One of the four fundamental forces is gravity. Forces that are constantly at work on us, steers massed objects. The remaining three are electromagnetism, nuclear forces, both powerful and feeble. These three additional forces were all until recently humanity was unaware of decades, but gravity this impacts everything, including sand. Grains to stars and planets has been the focus of conjecture for a while. It gives us the motivation to continue. The Earth's surface and keeps the Earth orbiting the Sun. The gravitational pull of the Sun, which draws all of its component parts tightly, allows nuclear fusion that generates heat and light, or simply put, gravity creates life. In an attempt to comprehend the world, early thinkers create their own theories as to why things fall approaching the Earth. However, it would require Newton's moment of the ability to change gravity from an irrational propensity of items to a measurable and predictable phenomenon. The straightforward explanation of gravity says it is the force that pulls a body toward it, toward the planet's center, or in the direction of any other physical body mass. The British physicist and mathematician, it is well known that Isaac Newton claimed, had no concepts of how gravity worked. Operated instead, he made use of the idea there was a single gravity, that an apple was created by the same force the moon kept, as well as to fall from a tree in space, as the basis for his explanation of it. When in use, his renowned 1687 treatise Major Naturalistic Philosophies Mathematica, usually referred to as the Mathematical Newton's Principles of Natural Philosophy, explained how the force of gravity can be determined by multiplying both the two items' respective masses, and then dividing by the distances square among them. As a result, gravity's attracting force acts any of the objects' masses up, or when they come nearer to each other. If we were to calculate this by doubling a single object's pull is doubled by its mass as powerful, and double the distance between two items, their mutual tug by four. These ideas were distilled into gravitational general law of Newton. It is typically expressed as Fg equals g m1 m2 in parenthesis slice r2. Newton described gravity as being precise enough to establish the presence of Neptune in the before anyone could even see in the 1800s. Newton's law isn't perfect, though. In the 1800s, astronomers discovered that a slight difference existed between Newton's law and the natural laws apply when they saw the ellipse created by the orbit of Mercury was revolving around the Sun rises more quickly than Newton's expected theory. The person who solved this problem is Albert, a German-American physicist. Einstein, in his general relativity theory written in 1915, Einstein proposed that the contours of the origin of the universe is spacetime, the force known as gravity. All things having mass, including the Earth, really flex and arc the material of the physical spacetime universe, as well as the curve what we experience as gravity. Even the light rays that must come after this curve is bent by an extraordinary amount. Enormous things. Generalized Einstein's field equations, relativity equations illustrating the behavior of matter and spacetime, distorted by energy, gained acknowledgement when they are accurate. Predicted the modifications in Mercury's orbit and the star lines curving around the Sun during a solar eclipse in 1919. Does that indicate Einstein was proven incorrect? Newton, scientifically speaking, concentrate. Newton's approach was detailed, and he adhered to an observational phenomenon, to a simple mathematical problem. Even though his mathematics failed to how gravity works, both then and now, is a tremendously successful method for describe the behavior of ordinary things. Einstein's accomplishments included increase our understanding of the genesis of gravitational force. It has been established that black holes exist. The topic of conjecture employing beliefs of Einstein at close proximity to a black hole law of gravity no longer applies accurately explains how motion of objects instead. Einstein's tensor field equations are prioritized. Astronomers have since discovered actual black holes in the universe and even able to capture a photo of the enormous one that is located at the galactic center. Various telescopes have looked at the impact of black holes nearby cosmos. Astronomers tested Einstein's theory. With the assistance of these black holes, scientists believed they may discover infringements of general many phenomena were explained by relativity of black Albert Einstein. But maybe holes. The graceful gravity model shown in general theory of relativity by Einstein is said to fail as the laws of the entire cosmos collapses on itself in the murky depths of these massive objects in the sky. In a study that was journaled, scientists have looked into the Sagittarius's enormous black hole in the galaxy's Milky Way center. The research demonstrates how gravity acts precisely as Einstein foresaw, even at an extreme black hole edge Sagittarius as an illustration. However, the study is just the opening salvo in an extensive research to discover where the Einstein model is broken. Analysis co-author and astrophysicist Jessica Liu at California University of Berkeley said currently available technical capabilities to put gravitational theory to the test. That has been impossible for us to test before. Einstein's gravity-based hypothesis is unquestionably in our sights. The researchers kept an eye on the star SO2, and when it came the closest in 2018, during Sagittarius' 16-year transit orbit, the star came within 120 yards from the black hole in astronomical units, traveling at a speed of 2.7% the rate of light. Astronomers made use of the Keck Gemini Observatory as well as Hawaii Subaru Telescope will track 3D orbit of SO2 in its entirety. Measurements were combined with this data, something they had already captured 24 years. Considering Einstein, the black hole would cause a warp in spacetime that enlarged the light's wavelength starting at S0 to 2. In essence, the waves would lengthen as the powerful gravitational pull of the black hole sapped their strength and altered the star's brightness changes from blue to crimson. That the star was still there, creating a blue light source, would help. Unlike Newton's theory of gravity, which the bending of time and space, it would have proposed an entirely different if the color had altered. The idea of gravity, nevertheless, as Einstein foresaw, the red-colored star. Researchers examined a broad known as the relativity forecast cosmological redshift. It claims that changes may be made to light using gravity principle. Researcher Tuan, despite an atheist working at the University of Cali, Los Angeles, reported these readings from space.com indicate the beginning of a time when we can finally evaluate the gravity's properties using the star's trajectories around a supermassive, the galaxy's galactic center's black hole. This has been eagerly awaited, hypothetically speaking, but it's incredibly interesting we can finally do it. This is a significant step toward the future. More effective general theory tests theories of gravity besides relativity. The S02 investigation is one of many general relativity theories. Studies that scientists want to do a star out on nearby Sagittarius stars. S0-102 is one of these targets. It requires 11.5 years to finish one more than 3,000 stars' orbits which are in the vicinity of the supermassive black hole. Based on the research, Andrea Guest, co-author of the study's lead author, professor of astronomy at the University of Los Angeles, California, said in a statement, "Our findings are in line with the general relativity theory of Albert Einstein. However, his theory is undoubtedly demonstrating vulnerability that is difficult to explain: black holes' internal gravity, and eventually, we'll have to relocate." Advancing past Einstein's hypothesis to a more thorough theory of gravity that explains to scientists what a black hole is. Be aware that a black hole has a point in time. Einstein's theory also ceases to be valid. Nobel Prize-winning author Kip Thorne, the California's Theoretical Physics Department Instituto de Tecnología, reported that the enormous curvature of spacetime that general relativity by Einstein falls short. We don't know how it operates when the situation you're in is severe. Researchers intend to employ a novel production of powerful instruments to conduct additional gravity experiments nearby according to black holes. Within the next 10 years should allow us to push according to Einstein's theory of gravity limitations and ideally begin to detect fractures in this field. There will be a revolution of physics. It is quite challenging to understand how current developments in underlying physics could impact our daily routines, our universe's beginning, and how we reached the present spot. Possibly about 14 billion years later, a new theory of gravity explains nonetheless. What are your thoughts on this? What impact will this have on our knowledge of the universe? Please provide your feedback in the box below. Give this video a like if you enjoy it. Give it a thumbs up and consider subscribing the channel for later watching.